All right. Hopefully everybody can hear me. Good morning. Welcome to Math 162 Pre-Calc 2 with TCC. I am Rodney Beckner. I will be your guide along this mathematical journey. Hopefully we are all prepared for this course. Math 161 is a prereq for this course. That's Pre-Calc 1. If you haven't taken that course before, I'm not sure how you ended up in here, but enrollment will find you eventually. And we do expect you to have remembered a decent amount of material from that course. Lots and lots of things, as well as math from before that time as well, dealing with fractions, dealing with decimals, factoring, rationals, radicals, all sorts of prereq material in this, as I mentioned in the email. Which, by the way, I did send an email yesterday to everybody. If you have not received it, well, you probably just need to check your emails. If you signed up for this course after roughly 12 or 1 p.m. yesterday, then you would not have received the email. Please shoot me an email, and that is at rbeckner at tcc.edu, as you can see right here, and I will forward that to you. But all of that information is basically going to be discussed today anyways, but it's still nice to have it in a physical form. So we will be conducting this course entirely over Zoom. We'll never meet in person. There will be no paper, pencil, physical tests or anything like that. They'll all be online, although you will be responsible for showing your work and submitting it to Canvas. We'll talk about that later. Make sure that you have written down the course ID for Mymathlab. Again, that was emailed to you. I know at this point, like 2 of you have enrolled, but I will need everybody to enroll by tomorrow, by 5 p.m. tomorrow, and we'll talk about that later. But for now, you do see my office phone. I'm not going to be in my office at all this semester. We're still doing the virtual thing, so I have to work from home, which is a lot of fun. Like many of you, I have lots of people here. I have animals here, people coming and going, construction every now and then, and stuff like that. So because of that, what you'll find is I like to do kind of these live introductions, and then I'll have pre-recorded material, and I might interrupt it here and there and do some more actual live stuff, but it'll all flow very well together. And I'm going to do the entire syllabus discussion live, but once we get to the material today, we'll switch to something that's pre-recorded just so we kind of get used to that setting. Now, you'll notice that I do have everybody on mute, and I'm going to keep it that way. Unfortunately, uh, attention spans are such that being able to hear crackling audio and stuff like that, and kids screaming and yelling in the background, whatever might happen, it doesn't work well with actually processing this, especially when we do the pre-recorded stuff on top of that. So if you ever have a question while class is going, you can ask in the chat, which I will pull up the chat menu real quick. If you go to your Zoom menu, mine is under more, and then you can find the chat. And there it is. So if you have any questions along the way, you can ask there. And if I'm actually talking live, it might take me a few minutes to get to it. If we have the videos going, I'll generally answer immediately, unless I have 6 or 7 or 8 messages coming in all at once, which this is a small class, so I don't anticipate that being an issue. If for some reason 5 minutes goes by and I don't answer your question, just please post it again or say, hey, what's the status? Occasionally, when I'm using my second device for the chat, sometimes it crashes. And when that happens, I lose the entire chat log. So that could be a reason why I haven't answered your question, but I will always answer questions. So if for some reason you haven't gotten your answer, just post it again and I'll get you. Office hours are still TBD, to be determined. Mymathlab.com, that is the main website we will use throughout this semester, in addition to Canvas, where you will find your live lecture link, as well as previously recorded videos. That's the beauty of this online format, is that anything that we do, I hit the record button, and then when the lecture ends, it takes 10 or 15 minutes to process it. I upload it to YouTube, I do this and that, and then I post a link to that in Canvas. So if you ever have to miss a class for whatever reason, there is literally no excuse to miss the lecture because you can go back and watch it. All right, so again, email rbeckner@tcc.edu. When you email me, make sure that you say you're in Math 162. That's all you got to do in the title of the email. In the title, make sure you say Math 162 and then whatever else you want to say. If you don't say Math 162, I'm teaching 3 other classes this summer, and I'm not going to know which class you're in. And then I've got to spend 5 minutes figuring that out. Or maybe I just reply to your email and say, well, what class are you in? And then that'll be it. Now, typically for pre-calc 2, the questions are a little more obvious. So y'all get a little bit of slack there. If you don't, I can usually figure it out really quickly unless you ask very generic questions. But for my quantitative reasoning students, it's impossible to pick them apart. Because that's what I teach multiples of. So again, please just make sure you have Math 162 in your email title just to make it as easy as possible for everyone. I will get to emails within 24 hours, within one business day. Weekends don't count there, although I'm not saying I won't answer emails over the weekend. I'm not going to guarantee that I will. It depends. I often go to places that don't have internet access. And if I don't have internet access, I can't reply to emails, but that's weekends. All right, so we're going to go through the syllabus at a moderate pace. We're going to show how to get into Mymathlab. We're going to show what Canvas looks like. We're going to show your materials, what the homework looks like, what the textbook looks like, and then eventually, after maybe 75 minutes total, we will get into actual trigonometry, actual course material. So please use your time to look over the syllabus on your own as well, because I'm not going to discuss in great detail everything like every single one of these topics. But course description, this is mostly a trigonometry class, but you could also call it an advanced algebra with trigonometry class, because the last third of this course, we kind of stray away from just trig and we go back to more of an algebra basis of things that we'll see again at the end of the semester. But the first 2/3 to the first 75% of the material all heavily relates to each other. We're going to be talking about components of a circle and angles and the sign of these angles and the inverse trig functions and blah, 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 all sorts of stuff. And trigonometry is one of my favorite math subjects in that it all, and I do mean this as sillily as possible, sillily, it all comes full circle. It's all related to each other. You can fully understand trig by just really knowing 5 or 6 or 7 concepts and then just extending them to the 30 or 40 that we go through altogether. But there is a decent amount of formula memorization. There will be some formulas, their own formula sheets that we'll see way later in the semester, but there is a decent amount of memorization and processing in here. If you're not as good with memorization, a lot of the things I will show you how to develop on your own just with a couple of quick tricks. Sometimes the tricks aren't super quick, but you'll get the idea. Required course materials, Algebra and Trig 6th edition by Blitzer, as well as the Mymathlab Access Kit. Now, technically, the textbook itself is an optional purchase because you will have an electronic text available by purchasing the Access Kit. Now, if you had Math 161 with TCC, specifically the Portsmouth campus and maybe, I want to say Chesapeake, it's either Chesapeake or Norfolk, but don't hold me to that. I only deal with the Portsmouth campus, so I can only speak for the Portsmouth campus. But if you had 161 Portsmouth campus with the Blitzer book with the same Mymathlab access, you do not have to purchase that access kit again. Now, if you had Math 161 and you weren't using Mymathlab or you weren't using this Blitzer book, then you would have to purchase the access kit again. Unfortunately, I have no control over that. That's just the way it works because it's a combo course essentially, but only if you're using the same materials, and not all campuses use the same materials, unfortunately. I do recommend that you have a graphing calculator. TI-83 is great. TI-84 is awesome as well. There are plenty of other options out there. The access kit might say first edition, but that's not talking about the textbook. It should be fine as long as when you use the code, it should work. But again, no physical textbook necessary. We do recommend the graphing calculator. The calculators are not going to be allowed for the first and I believe second test, but I will allow them for the third test and the final. So we kind of split the course in half about when we are allowed calculator use for a test and when we aren't. So we will use calculators lightly for the first 2 tests worth of material, but everything that we'll be testing on, you won't need it at all. I can promise you that. And when I say need, I mean, if you've learned the material appropriately, you wouldn't, quote, need it. And I'm making air quotes with my fingers. You just can't see that. My webcam is very much trash, so you won't see me for this semester. Just hear my voice. Okay. I have a digital, where is it? TI-83 that you'll see me use. I meant to pull it up before class. There we go. So this is what a TI-83 looks like. I imagine most of you have seen one before. And if you email me, I can tell you places that you might be able to find this, like if you type this in a Google search, but unfortunately, I don't know if legally I can say exactly where to find it. It's one of those situations, you know what I mean? Because this is a ROM. So I don't want to break any laws, especially in a recorded video, but I can tell you clues to find it. I just don't want to do that in a recorded video. Textbook materials, in other words, just the thing that you absolutely need, the Mymathlab Access Kit. You can purchase through the website. You can also purchase at the physical store, but I know the beginning of the semesters, they tend to be short on access kits. I know my 154 students said their access kits aren't there right now, but the good thing is you get a 2-week free trial as mentioned in the email. So that should not be a problem. Generally within a week, everything is restocked. If it is taking longer than 2 weeks, then I'll deal with my publisher to figure something out. Learning outcomes and topics, solving trigonometric equations, dealing with right triangles, eventually dealing with non-right triangles, which we call oblique, dealing with identities, evaluating expressions, blah, 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 eventually getting to conic sections, and then dealing with series and sequences. We might not get as deep into conic sections as I'd like. It'll depend on how time goes, but we'll see, again, how time goes. So I'm not going to read every single one of these topics covered in the course. Spend your own time doing that, but eventually we will hit all of these except for the optional stuff. Definitely won't get to the optional stuff. There's no time for it. I don't want to say it's a joke that they put that in there, but a teacher who's teaching this course fast enough to actually get to the optional stuff, I'd be wary that the students aren't learning anything because it's so fast. I don't know, but maybe there's a awesome teacher out there that can do that. I am not going to speak for everyone. Description of assessment and assignments, homework and quizzes. That should not say WebAssign. I swear I fixed all of those. That should say Canvas. Homework will be in Mymathlab. Tests will be in Mymathlab. If I do any quizzes, I might put them on Canvas, but admittedly, I really don't do quizzes in this course. I find that most of my students are pretty good about doing the homework in a timely manner, and I only give quizzes when students aren't showing up to class and when they aren't doing their homework. So if out of my 10, 11 students, if I find that 8 of you aren't doing homework, then you'll start seeing quizzes. If I find that the majority of the class is doing the homework, we don't have to do quizzes. Tests will be conducted, it says in class, that's just an old memo. I can't modify everything in a syllabus. We have a syllabus builder nowadays, so I can only add little chunks of stuff. One thing that's going to be wrong in here is this course outline, this schedule. You can see that the weeks don't line up at all to this stuff, so don't sweat that. And honestly, even if it did, it was going to be wrong. The course schedule is just going to be as we get things done. There is no great way to predict when things are going to be ready in this course, especially if we have some power outage and I can't teach online, or we have some crazy storm come in. It might snow. I live in Hampton Roads. You never know what's going to happen with the weather. We'll have a hurricane in January and then snow in July. It's going to happen at some point. But again, you can just see these topics there if you choose to look at them. Course policies, you have the standard COVID plan. It says reopening for fall 2020. This is still valid. If you use that hyperlink, it should take you to the 2021 features. Specific course policies, again, another just old typo. Whoever has the master version of the syllabus needs to update a couple of things, but that's okay. So you have to you have to assume an active role in the learning process. You have to come to class. You have to watch the lectures. And again, if you can't catch the lecture live, that's what the YouTube links will be for. So again, I'm not necessarily taking attendance every day. I mean, I look at the participants and I copy them, but that's not my attendance. My attendance is going to be a combination of that along with, are you doing the homework? So if I find a student is attending the lectures every day, but they're not doing the homework, I can't say that they're actually attending the lecture, I don't know what you're doing. You might just have this on your cell phone in the other room. I can't prove any of that. So attendance is much more going to be based around your participation. So if you don't do the homework, I'm going to eventually withdraw you. If you aren't taking tests, I am going to withdraw you. So please, please actively participate. And again, with the recorded lectures, if I talk too fast, which I do tend to do sometimes, if you miss something, you can go back to the YouTube and replay it and replay it and replay it. Or you can use the slowdown feature. If you find that my normal talking speed is too much, then put it at 75% speed, and then you'll get me at a much more nominal speaking rate. But that's just my personality. I've had plenty of people ask me to slow down over the past 15 years of teaching. I do my best, believe it or not. I used to go faster. I have slowed down, but I just can't go at a snail's pace. It's not my personality. If you can't handle that, there are other teachers out there. That's the great thing about college. You get to choose your professors. Unless you're just stuck to a specific time. But I already said, if you can't attend class live, you can watch the lectures after the fact. So that's not necessarily an excuse anymore, at least with these Zoom classes. Grade policy, standard 10-point scale, A is a 90 to 100, et cetera, et cetera, et cetera. No plus or minus grades. You will find your final grade in SIS, aka my TCC, about 24 to 48 hours after the course ends. Which, by the way, if you look online, it says the course ends August 6th, I believe. That is very wrong. That is for classes that are based on Mondays or Fridays, because we have Memorial Day, we have 4th of July, and we have Juneteenth. And all of those holidays, or the observed dates, because some of those are on a weekend this year, are Mondays or Fridays. They don't affect Tuesday, Thursday classes at all. So we're actually going to end the week before that if all goes well. If we have to miss a class, I actually could use one of those days if I choose to make it up. But hopefully that's not the case. If you make it halfway through the semester, if the withdrawal date hasn't happened yet and I haven't withdrawn you because you haven't been participating, or if you've just been getting Fs on everything and you think you can't handle it, please withdraw from the course. That's going to be much better than an F overall. Unless you're military, I know that VA students, things work a little differently for them. So I can't really make an umbrella statement. Incomplete grades are really hardly ever given. It's very, 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 very extenuating circumstances, like for students that might be 9 months pregnant 4 weeks before the semester is about to end, or you're military and you've been uprooted somewhere else to Washington State or San Diego or something like that. I don't know. That's really the only times I's are given. So please, please don't let it just be the end of the semester and think, oh, well, let me ask for an I because I didn't do some assignments. It's not going to happen. You will need documentation of very extenuating circumstances. Let me just do this so everything's on one screen. Breakdown of your grade, which I know we're waiting for. Tests, 60% of which there will be three regular tests. Homework is 20% of your grade. And then the final exam is also 20%. So basically everything you do in here is 20%. Test 1, 20%. Test 2, 20%. Test 3, 20%. The final, another 20%. And then your homework is another 20%. Homework, you have infinitely many attempts on every single problem. There's no excuse not to make an A on the homework eventually. There are very awesome tools for most questions, like a help me solve this and view an example button that we'll talk about when we show Mymathlab in a little bit. And I give a 10-point curve on the homework, as we'll see me talk about a little bit later. So 90s turn into 100s, 80s turn into 90s, basically, but I'll talk about that a little bit more later. That is an excellent opportunity. If you make C's on all your tests, like let's say you made 76s, 77s on all your tests, but you knocked out all your homework average is a 98, that 20% is going to bring what was a C, if everything was just based on tests, up to a B. So that homework can make or break you. It can also do the opposite, as I just said, make or break. But you might be making A's on all your tests, and you think you're an awesome student, so you don't do the homework and you're still making A's on the tests, and that's awesome that you can make A's on tests without doing homework. Almost makes me question, what's going on. And if I saw several students have that happen, but then you're going to have zeros for all your homework. You're not going to get the 10-point bonuses either because you got zeros. And now your A grade is going to be a C, and that is gonna hurt. So do not excuse yourself from doing the homework. Do not be lazy. Find a reason to complete the homework. Think about what your end goal is. Why are you here? You're probably here to eventually make some money. Think about that future money you're going to make, or maybe you're here to help support someone, or maybe you're just here to learn. I don't know, but think about why you're here and motivate yourself. You need to spend a ton of time outside of this course studying. There is an expectation of how much time you put into this course that, again, we'll talk about in a little bit. I've got an extra little sheet of stuff here to talk about. So that's why I'm just kind of putting some things to the side. Course communication, it's pretty much email me, shoot me a message through Canvas, shoot me a message to my email address that we mentioned earlier. Attendance, we already mentioned that because this is an online course, attendance is going to count as homework completion and test completion essentially. And 15%, hold on one second, I'm sorry. You're actually going to have to give me about 2 minutes. So I have my dog in the other room. He's very, very, very needy. I have 2 dogs, and one of them is very needy. He's old. He's got health problems and everything. He makes a ton of noise, but unfortunately, because I locked him in a room, he is borking over and over and over. So I need to let him out and just have to deal with this noise. So give me 2 minutes. Sorry about that. Real life is fun, isn't it? This is much easier to handle when we're in person. And I'm going to apologize if you hear my dog pant really loud or snorting really loud shortly, but it is what it is. He was up there panicking. All right. And like I said, this is a reason why I like to use some pre-recorded material. I can do this at night when I have my significant other here and I can go in a room and lock myself away. When I'm at home without her, it's another story. All right, so 15% of attendance being missed, what that means is for a summer class, you can only miss 3 days. So if you miss 3 days worth of homework, I can technically withdraw you at that point. Now, am I going to immediately withdraw you because you missed 3 days of homework? Well, it would be 4 if you missed more than 3. No, that's not how I'm going to do it. I do give you a little bit of time to catch up and everything. And especially if I do see your name in the class, I like to say, okay, well, they just need to get 1 more done. But if you start missing 5 homework, 6 homework, 7 homeworks, that's when I'm definitely going to withdraw you. Da, 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 da. Attendance. You see attendance like 5 times in this. Late workup, makeup work. I don't really do late homework unless you have extenuating circumstances. If you've got documentation, then I can give you an extension. But generally speaking, homework is due 1 week after we complete a section. So if I were to complete 5.1 today, which I won't, that means 5.1 will be due the following Tuesday, and the due times are always 11:59 p.m. that day. So you would have until the second before midnight of that day to complete it. I'm not going to say it's due at 2 p.m. or 7 p.m. or anything like that. It's due at 11:59 p.m. Tests and homework will both work that way, and quizzes, if we give any, the same thing. Classroom behavior, not really an issue since I have everybody on mute. Just don't say anything obscene in chat and we will all be friends. I'll respect you. And yeah, electronic devices, again, not really an issue except for during testing. Cell phones may not be used during testing. I do reserve the right to do Zoom recordings of you testing, so you might have to use your cell phone or a webcam or something like that. It's not something I always do. It's something I do occasionally. So admittedly, I won't do it for the first test because I want everybody to kind of get used to the swing of things. But the final exam is typically where I say, all right, I'm probably going to do that. Inclement weather, hazardous conditions, anything like that, not too big of a deal for a Zoom course. If I don't have power, I can't hold class, I'll try and get an email out if something like that ever happens. If I'm sick, again, I'll get an email out as soon as I can. Unfortunately, I'm one of those people that I definitely, maybe I wouldn't say unfortunately, but I'm one of those people that I definitely try and make it no matter what, unless it's, COVID type symptoms, anything like that. Nope. Um, we're gonna back out. But since it's online, if I can do this, that's fine. So if I feel sick the night before, I might not cancel class until the morning because I want to see how I feel in the morning. If you haven't signed up for TCC Alerts, please do so. It will send you text messages and emails about anything going on, whether it's a lockdown on a campus or it's a hurricane alert or a tornado alert or a snow alert, anything like that. I had a situation over a decade ago where I did not have TCC Alerts, and I regretted it after I got to campus and school was closed for whatever reason, and immediately I signed up for TCC Alerts. Withdrawal policy. So our deadline to drop for tuition is June 4th. That's not too far away, just a week and some change. And then the W date is 7/8, July 8th. That's the 60% mark of the course. So you can't withdraw after that without some crazy extenuating circumstances. So if you want to withdraw, make sure it is before then. Also, if I'm going to withdraw you, it will be before then. If you withdraw after that, or if I withdraw you after that, you will receive an F instead, unless, again, extenuating circumstances. Academic integrity. Tests need to be your own work. Again, if I suspect other things going on, I might start doing the recorded tests sooner than later. I can use lockdown browsers. I've got all sorts of tricks and tools for this. If I think that funny business is going on, oops, didn't mean to hit that button. Homework, I would encourage you to find a study buddy. Find one or two other people in this course if you want to, and work on the homework together. Because it's online and interactive, you will have different numbers for most of the questions. But if Bob and Jane are in a study group together, if Bob understands his problem, Jane might have different numbers, but Bob could help Jane, relate from one to the other. Plagiarism, don't cheat, don't get caught cheating. Pretty easy stuff there. Educational accessibility. If you have any disability service form, educational accessibility form through TCC, please email it to me. They've probably already instructed you to do that unless you haven't got one yet. If you do feel that you need accommodations, but you don't have TCC paperwork, please talk to CCC because that's the only way I can do anything, but I will absolutely 100% give you the accommodations that your paperwork says. I will not accommodate you in ways that it doesn't say, though. Some students occasionally will try and circumvent what it says, and I go, well, no, this is what it says, and this is what I'm going to do. So please understand your accommodations. And again, I will absolutely accommodate you. There's other schools that don't always do that. I've heard of some schools where they'll say, oh, well, you have to allow taping of lectures. And then the professor says, well, no, that's copyright infringement. I mean, I don't know. It doesn't seem like copyright infringement to me. Who cares? If you want to record the class, record the class. And for us, it doesn't even matter. I'm recording the class for you and posting it for you. So we're all good there. I just like to keep things simple as I can. You might say, well, why are you giving us a 17-page syllabus? That's not my choice. When I started teaching 15 years ago, the syllabi were 2 pages long. But the 2000s have complicated lives. We have a library on campus. Go check it out. Their hours are posted there. We have a tutoring center on campus as well as offering digital tutoring services over Zoom sessions. Whenever they have the hours and the link for that session available, I will make sure everyone gets it. They do tutor Math 162, so that will be a great free resource. That's room A110 on the Portsmouth campus, by the way. If you're not a Portsmouth student, you could use your associated campus's LAC as well. That would be fine. I just can't tell you what room it's located in because I'm Portsmouth. Really cool websites, and the one up here that I'm gonna mention is Khan Academy, KHAN, and then Academy. And if you just Google it, you can find that really quickly. It's an awesome resource if you're rusty with your Pre-Calc 1 material or even further back. Awesome material there. If you're going through Trig and you find that my resources aren't good enough, you might be able to find something on Khan Academy that would better work for you. Also, purplemath.com is pretty cool. So check those two out if you do need some more online resources. But again, everything else is pretty clear, cut, and dry. I don't want to waste too much time just talking about the syllabus because we need to get into everything. Classroom behavior. I don't know why they have so many things repeated now. It's so pointless. I mean, I really feel like I just need to talk about attendance. Can't miss more than 3 days. Grading policy, 20% per slice. Test, 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 final homework. Boom. Sections involved. There we go. Course ID for Mymathlab, which most of us still need to sign into. Beckner 96719, and that's exactly what we're going to do right now. We're going to show you how to do that. Just going to hit copy there. So let us go to mymathlab.com. If you already have an account, you can sign in and then register, but I'd rather just go to register now as a student because you're a student. It tells you what you'll need, your email address, your instructor's course ID, which you will have both of those things. This third one is not mandatory right now, but within 2 weeks you do need it to actually pay for this. Okay, register now. Enter your course ID. That's where you'll type that Beckner 96719 for the summer 2021 course. If for some reason I'm using this as a slice of pre-recorded material later, then if you're not in the summer 2021 course, don't use that ID. Continue. This is where you could sign in with your account if you have one already, if you're coming from Math 161 or 154 or something else. If you have a non-math, like a My English, whatever, that would also work. And it should say Math 162, et cetera, et cetera, et cetera. I'm going to show you how we create an account. Type your email address, pick a username, pick a password, re-enter your password, follow the passwords guidelines, write down your username and password, write down the email address that you use. Your username can be your email address, that's up to you. If you're using a TCC email account, it should be something like Bob1234 at, and here's the important part that some people mess up, email.vccs.edu. If you miss a C, you're going to have problems. If you miss one of those chunks of words, you're going to have problems. You're going to try and sign in, and they're going to say, oh, you don't have an account. And then it's going to say, well, type your email address that's related to it. And if you're typing the wrong email address, they're going to say you don't have an account because you created an account with a bad email address. So quadruple check that to make sure it's right when you're signing up. You can use your Gmail account or whatever. I personally don't care. I'm supposed to tell you to use your TCC account, but I'm going to say use the account that you check. First name, last name, security question, etc., etc. I can't show you if you already have an account, unfortunately. You would have to figure that out on your own. Make sure you agree to their terms. If one of these conditions applies to you, you can click it. If you don't want to receive a bunch of emails, you can click there. And then you'll hit the Create Account button. Now, unfortunately, I can't take you past this screen. So what I'm just going to do is draw what the next screen looks like. So you don't have your access kit yet. That's okay. So what you do is, on the next screen, so this is the screen after you hit that Create Account button. You'll have a button. Actually, that's not going to say buy. It's going to say use. There'll be a button here that says use the code. So if you already got it, you click that and enter your 20 or 25 digit code. You'll have a button here where you can buy your code. So if you don't want to go through the Barnes & Noble bookstore and you have a credit card or a debit card, or I think they take PayPal now. Maybe one day they'll take Bitcoin and Dogecoin and all that jazz. But you could buy directly from them. It won't be exactly the same price, and I forget which is more or less, because I think our pricing format's changed in the bookstore due to competition, but don't hold me to that. But if you don't have your $75, $80 right now on you, what you can do down here, and then of course it's smaller font, it'll say something like blah, 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 14-day free trial. And it might say 2-week free trial. It's a blue hyperlink, but that is where most of you are probably going to click so that you have access for the first 2 weeks. Now, after those 14 days are up, if you haven't entered your code, it's going to lock you out. It doesn't delete your work, it just locks you out. Once you enter your code, you're back in, all your work's still there. But let's say it's been 2 weeks and you're locked out and you don't buy your code and 3 weeks pass and I don't see any participation from you for 3 weeks. What happens? You guessed it, I withdraw you from the course because you haven't been attending. The tests are in Mymathlab. If you don't buy your code, you can't take the tests. You can't do the homework. You will fail automatically. You're going to get a 0. Some students might say, well, could I just complete everything in 2 weeks? Well, you could complete all the homework, but I will not give access to the tests early. I'm just not going to do that. So no, you can't complete the course in 2 weeks, as awesome as that would be. And again, if you're coming from 161 using the same text, using the same internet resources, it should just be automatic. But again, I can't tell you if that's your case. You have to figure that out on your own. All right, so when we log into Mymathlab, it'll look like this, but you'll have way less courses. And you'll specifically see this one at least in there. Math 162, Tuesday, Thursday. Ooh, I got more people enrolling while we're doing this. So awesome. Love y'all very much. Just got to get, I think, 4 more and we got full participation. In here, you can find your syllabus, which I did email you. You can also find your syllabus in Canvas, which we'll get to Canvas sooner than later. So same exact syllabus. Homework is where you'll spend most of your time. Quizzes and tests is where you'll spend a little time later. These chapter 1, chapter 2, chapter 3, skills check, all this stuff, this is not anything I assign. You shouldn't even have access to it. If you really want access to it, you can email me and I'll give it to you. But it's not something that I just generally make available. But you'll see those tests added as they become available, as the test dates approach. Well, really only during the test dates. Here's your homework. You will also find reviews in here eventually, but this is every single section of homework we'll be responsible for. As the semester progresses, the due dates will be placed in here, again, 1 week after assigned, 1 week after completion. If I complete 5.1 and I don't say it's due in a week, you are to assume it's due in 1 week. That is an automatic assumption. That is the course's rule. However, 99.9% of the time, I am good and say that it's due in a week. I generally put due dates and stuff on the what I would call a whiteboard at the beginning of class before moving on to a lecture. So chapters 5, 6, 7, 10, and 11, that is what we will be covering in this course. A little bit of a hop, skip, and jump here and there, but that's okay. You can go to your grade book and find your grades. I can't really show that though right now. I don't want to reveal anybody's grades. Tests are timed. Quizzes would not be timed if we do any, and the time limit for tests, it's either an hour and a half or 2 hours. Don't quote me on that, what I like to do yet, but you will be told what that time limit will be, and then if you have accommodations, I will accommodate you with that time limit as needed. You would get a little more time on the final, but yeah, and I'm going to talk about tests a little bit more sooner than later. Your e-text. So this is why you don't have to purchase a physical text, although I'm old school. I'm not that old, but I am old school. I like to have a physical text, so I would purchase this for myself, but if you're fine with just an e-text, then just do the access code only. I'm not going to force you into anything. I will say sometimes the e-text loads slower than other times. It's actually really doing really well right now. Chapter contents, if you don't want to just open the e-text that way, this will get you a little quicker. Oh, well, chapter 5, 5.1, view the e-text. So that way I don't have to figure out what page to go to. So the chapter contents is a little better. I don't even know why they have both available. It should just be the one based on chapter contents. And this is exactly what your physical text would look like. Now, the one thing I want to show in the physical text that most of you are used to from back in the day, the homework pages. Whenever I get to them, because this is a long section. Here we go. So the homework in Mymathlab, generally, it's not a lot of questions, 10 to 30 questions, usually in the like 15 ballpark, maybe 20 for some sections. That's not a lot of homework questions for a math class. I find that most people learn math the same way that they build muscle or anything else in the world, repetition. If you want to know the sine of 30 degrees and the process of how to figure out the sine of 30 degrees, which we'll go into later, not today, later, you need to not just do it once. Oh, I got it right. Okay, I never need to do that again. You need to do it 3 or 4 or 5 times. What's the sine of 45? What's the sine of 60? What's the sine of 240? You need to do a bunch of these. What's the cosine of 30? So repetition is the key. Now, you can hit similar example in Mymathlab, but what you could also do is go to your physical text and just pull up these problems, and the solutions would be in the back of the text, so you'd have to pull that up separately. But this would be more practice. So it is my opinion that there are not enough homework problems in the Mymathlab shell, but I don't get to make that decision. So it is my recommendation that you do extra practice. I give reviews for tests as well. They will be, I mentioned that previously, they'll be in my math lab. It'll feel just like a homework assignment. So that will be an excellent resource. And my tests are similar to the reviews. So don't not do the reviews. That was a double negative intentionally, which means do the reviews. Anything else I need to say about my math lab? I don't really think so. I think that should be it. Syllabus, homework, quizzes and tests, gradebook. I already mentioned previously that we're going to see now this thing right here. Homework is due 1 week after the section is completed in class, unless I mention otherwise. Maybe there's a time where I have to make it due the next class because the next class is the last day of school or something like that. Or maybe it's a situation where I'm giving you a break and I give you a week and a half. Or maybe I'm just mentioning it earlier than later. But I do suggest that you complete all homework before the next class, not a week later, because we're going to be continually building and building and building. So if you do the homework before the next class, you're probably going to have a better understanding of what we're doing in that next class. As previously mentioned, any of my math lab homework that is a 90 or higher, I will change to a 100. Anything lower, I add 10 points to. I add 10%, 10 points, same difference, same thing. So this is a 10-point curve. However, I'm not going to give anybody 100 threes or 100 fives or 100 sevens or 100 ones or 100 twos. I'm just going to make your grade a 100 if you got a 90 or higher. Now that might influence a lot of students to just get 90s, but I mean, come on, if you got a 90, try to get that 100. The reason I really do this is because sometimes there's a question or two in there that are it's just a little wacky. It's good for students that really want to go more in depth to the material. But I also don't want to punish students that aren't going to be going on to Calc 3 and advanced this and that. Because of this curve that I'm not going to adjust in my math lab because it would be very time consuming. And for other reasons, don't trust your MyMathLab grade. First of all, your MyMathLab grade is not going to account for this up to 10-point bonus on each homeworks, which by the way, if you get a 0 on a homework, you're not getting the 10 points. You don't get something for nothing. But also any homeworks that you didn't do that should be counting as zeros, MyMathLab absolutely refuses to count them as a 0 unless you open it and close it, then it'll give you a 0. So if you never opened it, you think you're tricking the system. Oh man, it didn't even give me the 0. Yeah, it didn't in my math lab, but in my grade book at the end of the semester, it will have that 0. So that's why I'm saying you can never trust your MyMathLab grade. It's wrong. It's already wrong. It's wrong. So how can you do this? Keep track of your grades yourself. Open an Excel file, open a Word file. When you see that you got a 95 on homework 5.1, write it down as 100. When you see that you didn't do 5.2, write it down as a 0. Add up all those numbers and divide by the number of homeworks that have been assigned at that point, and you can get your homework average. It's as easy as that. We're trig students. We should know how to calculate averages. I would actually suggest what I like to do is have them in Excel. So that way, and then just an average formula somewhere, that way it can calculate it for you. And you can Google that, how to do that. You could also find my Math 154 videos on YouTube because my playlists are all public and I teach Excel in there, and that would be very helpful if you wanted to do that. If you don't know, every single one of you as TCC students gets Microsoft Office for free. And it's also something I show how to do in that Math 154 course, but it's something like office.vccs.edu. I believe that's the website. And then you can get your free Word, free Excel, free etc., all that stuff from there. I've already mentioned if you purchased access for 161, my math lab with the same book, you don't have to do that for 162. All right, good. Just practices for this course. This right here is a practice for every single course you're in, though, for a summer course. This is something they don't tell you, but if you have a full-time load of 10 credits, you're supposed to be working outside of class 30 to 40 hours in addition to that. 35 hours is about the average there, just doing homework and studying and etc. College is the exact opposite of high school. High school, you go to class 3 hours and then you do 1 hour of homework. College, you go to class 1 hour and then you do 3 hours of homework. So because we are moving 50% faster in a summer semester with 10 weeks instead of 15 or 16 weeks, that means what would normally be 6 hours of studying turns into 9. So you have got to dedicate a solid chunk of time to studying and working on this material. Now, if you're awesome at math, maybe you're doing less. If you're not awesome at math, maybe you're doing more. But this is a dedication that we expect from you. If you're not putting in the hours, you're going to have a tougher time usually with this material. Take good notes. Don't just watch me do this stuff. Take the notes. A lot of us learn by writing. Some of us learn by reading. Some of us learn by listening. It just depends on your learning style. If you can figure out your learning style, that would be very, very awesome. Me in particular, if you tell me something, I'm not gonna say I don't listen too well. It's just the way my brain, it's just the way my brain works. Whenever you click a link in Canvas to a YouTube video, you'll be able to see my YouTube name. It's what is it? RCB TCC Math. It's something like that. But again, as soon as I have that first YouTube link posted in your Canvas shell, which we'll talk about the Canvas shell soon, then you'll be able to see my TCC account, my YouTube account, I mean to say. So take good notes, especially if you learn by writing, but that's also just great to have for later. Instead of having to, oh man, what video was that on, and having to dig through videos and fast forwarding and clicking here and here and here. Some people that's going to work really well. Some people it won't. Make notes of what videos a particular lecture happened. I label them based on sections, but not necessarily all the topics. So maybe labeling things with topics and section numbers would be good, but good notes is going to help you. But as I was saying, I don't really learn that well by listening. If someone talks to me for 30 minutes and tells me 10 things, I'm going to forget 9 of them. But if someone talks to me for 30 minutes and I write them down, I'm going to remember all 10 of them forever and ever and ever. It's just something about putting ink to paper. It sticks it in my brain. I also learn by applying things like most people, which is why I say you should be trying to process this stuff as we move forward. We will get to that when we talk about Canvas. Spoilers, it's Canvas. Someone asked a question. Homework will count as attendance. We talked about that. Don't ask for extra credit one day before the end of the semester. That is a big pet peeve of mine. Again, this is not a high school class. This is not 13th grade. This is college. If you are struggling, talk to me 3 weeks in, 5 weeks in, not at the 11th hour. Don't miss tests. If you have to miss a test because you're sick or something, let me know. Or if you have some crazy work thing going on, let me know. But I don't really do makeup tests without some form of documentation with this online process. I might have been a little more lenient about that in person, but I do require documentation here. So tests will have appropriate reviews as mentioned, given at least one class in advance to the tests. Tests will always be announced at least 1 week in advance. So while I'm not telling you test 2 is going to be on August 17th or test 3 is going to be on September 90th, both of those were not appropriate dates intentionally. I will let you know the test at least 1 week in advance, and tests are generally chapter based. So that's a really good sign of when it's going to be. And on top of that, the whole 1 week aspect, tests are generally 1 week after finishing material. That way you have time to learn it and study it. When you have to take a test, it will not be during class time. It will be on your own time, and you'll have 2 days to take it. I generally will have those two. I'll have the first day be a class day and the second day be the day after class. So maybe like a Tuesday, Wednesday, or a Monday, Tuesday. Actually, I might do a Monday, Tuesday since our classes are on Tuesdays. When I have Monday, Wednesday classes, I usually do Monday, Tuesday as the option. Just seems to make more sense. But again, you'll have 2 days, whatever it is that I choose, but one of them would definitely be a regular class day. Now you might say, well, Mr. Beckner, I don't have a single minute to take this test outside of class time. Well, guess what, Bob or Jane? That's okay. Take the test during our class time while I'm lecturing. Don't watch the lecture live. Watch the YouTube recorded lecture later that day or the next day, whenever, because again, there is no excuse to miss anything. So you can still take the test during class time. You'll just have to watch the lecture later. So test 1, test 2, test 3, which will be chapter or pairs of chapter based. There'll be 2 days, but the cumulative final exam that'll cover everything we do will only have 1 day. And I generally make that the last day of class for fall and spring semesters. For summer, I might have to play with that rule. I want to see where it looks like we're going to be ending. I would like to still have that be the last day of class because it just makes sense. But if I have to do it a different day, we'll talk about that, but for a month or two from now. So where do you submit your work? Because I said Mymathlab tests aren't, okay, I might not have said this actually. Mymathlab, when you take your tests, it's going to tell you you're right or wrong. But this may have been a problem that had 10 steps and you did 9 of those steps right, and it's not going to give you any points for that, unless it actually has the multiple questions and answers, which is true of some problems. So what you do is you were supposed to be showing all your work while you're doing any kind of math, homework, quiz, tests. So you have your work nice and organized with your name on it on paper, and then you take a picture of it or scan it, and then you upload it to Canvas, which will show you where those locations are in a few minutes. And you have to submit your work to make sure there's no funny business going on no later than 15 minutes after finishing the test. So when you finish the test, I go in Mymathlab and I see a timestamp. And then when you submit your work in Canvas, I go in and I see a timestamp. And if there's more than 15 minutes between those two, I refuse the right to accept your work. I refuse the right to actually give you a 0 for your test as well, although it's generally not going to be the case. If you don't submit work, I do definitely reserve the right to give you a 0, because then there's no proof that you actually did anything. So problem number 4. You did 9 of these 10 steps right, but it didn't give you any credit because the answer was wrong, so you're wrong. But you showed your work, you submitted the Canvas within 15 minutes, then you email me and say, hey, Mr. Beckner, on test 1, question 4, 5, or 6, whatever it was, check out my work. I think I've got pretty good work here. And I'll go, oh, yep, I checked it out, and you certainly did. Here's 80 or 90% of partial credit on the problem, or 60 or 70, depending on how much you deserve, of course. But I am a big believer in partial credit. So please, please, please show your work and earn as much as possible. But take note, partial credit is only done on requests. I'm not going to go and look at everybody's work individually for every single problem. It would take me an absolute bonkers amount of time with this online format. It was much easier back in the day when I got just a stack of paper in front of me and I can flip through it super fast. It takes 30 seconds to load these pages. Half the time they aren't zoomed in appropriately. Half the time the students aren't doing problems in order. Please number your problems. That's okay. I don't care if you're doing them out of order as long as they're numbered, but there's lots of complications. So please make sure you send me any partial credit requests. Words are hard. We already showed that screen before for the Mymathlab access. So let's get to Canvas. It's probably going to boot me, so let me sign back in. I think we're on just about the perfect schedule so far. Canvas. So you won't have nearly as many courses as I do. Pre-Calc 2. And this is what your Canvas course looks like right now. Mostly you'll see some green checks and some little circles with line through them. So let's actually go to student view to show you what it looks like right now for you. So when you sign in, first thing you see is some TCC stuff, and I can move these sections around. So I actually like to have this one at the bottom so it's not in the way. The thing I like at the top is the lecture videos. So this was the link to the live lecture. And then after I finish the lecture today, it takes about 15 minutes for Zoom to convert the file into something I can put on YouTube. And then it takes YouTube maybe 15 minutes to process on top of the 5 or 10 minutes it takes for me to type all the little subtle things and hyperlinks and blah, blah, blah. But at some point, maybe an hour after class, you'll have a link to a good video. So it'll be immediately under this for today's class. And then the next class would be immediately under that. So as the semester progresses, it will expand. And then where's exit? Move student view. I like to have, you'll never see these, but this is just an old one. But by the end of the semester, you'll have 20 or 21 links. So this is what it'll look like later. You have the live lecture always at the top, and then the intro, then the next day, and the next day, and the next day. And this was a fall class, so we won't be at the same pace. This is more links than we'll have. Again, we'll only have about 20 of them. But some other things that you will eventually see, a formula sheet. Oh no, I do have that visible right now, excuse me. But the submitting of the test work. So I don't have it visible right now, but whenever test 1 is available, this link will be there to submit it. So you go in there, And then I can't actually hit the proper buttons, but you'll have a button to submit your work in there, and then you can upload a file. It's pretty easy to figure out. I would suggest that you go in there and look at it before you start your test, though, just to make sure you're not going to have any issues. If for some reason I forget to make that live, don't panic and don't email Mr. Beckner. Are you still going to take my work? Yes. If I didn't put that link up there, I will still give you credit even if you're 15 minutes late. If there's some kind of technical glitch, that stuff happens. I make exceptions to my blanket rules, but in general, it's a 15-minute submission time. And again, that's just to make sure if you submit it 3 hours later, how do I know you didn't change some things? How do I know you didn't make your work after the fact? It's really hard to complete an entire test worth of work in 15 minutes, especially since you're going to spend 5 of that uploading things. There is a discussion board section here that I have a general discussion here, just if you have any course questions, random stuff. I need to edit this. I only have the chapter 7 and 11 one open, but I will have one for chapter 5, one for chapter 6, etc. But most of the time you'll be spending in this section, like we said. The syllabus is also located here. I need to actually update that. I swear I updated that. That's an old syllabus. The one in Mymathlab is correct. I guess I just forgot to hit the save button when I did this. My bad. So again, right now, student view and Canvas for the main section. You're not going to see a lot of things. Why didn't it take me to student view? I clicked it. You'll see the one live lecture link in a couple hours. You'll see the link from today's lecture, and you see the trig formula sheet. And again, it's a sum because it's not every formula for this course. It's just something that will be allowed to use later. So how do we submit our work for a test? We go to Canvas, a picture file, a scanned file, whatever. If for some reason you're typing your work, that's okay too, but I really can't imagine a lot of people are typing their trigonometry work. It's quite time consuming. Where do we do our homework? Mymathlab. Where do we take our tests? Mymathlab. Where do we find our electronic text? Mymathlab. Much easier to find in the chapter contents section. Where do we find our syllabus? Email, Mymathlab, as well as Canvas after I update it. I think that's all I really need to say about the outline of this course. Homework's always due in a week. Tests will be announced within a week of when the dates are. Tests are 2 days. The final is 1 day. Calculators will not be allowed on test 1 and 2, but they will be allowed on test 3 and the final. And that's because with test 1 and 2, your calculator can do half of the material for you, and then you're not actually learning anything. So I gotta make sure that you're learning the processes. I'm one of those teachers that is very accepting of multiple methods. In general, I don't care how you get an answer as long as you get it through some knowledgeable method. For example, the sine of 30 degrees is a half. Now, some students memorize what we call the unit circle to know that. And that's cool, but it's not my way of doing things. If you're a student that does it that way, perfectly fine. You'll be fine all semester. You'll get your answers right, and we won't have any beef or chicken or fish. It's about lunchtime, so I'm hungry. Sorry, I had to say that. But while I particularly wouldn't memorize the unit circle, I like to stress what I call the 2-triangle method. There's 2 right triangles that paired with a couple other details that can actually figure out the entire unit circle by using logic, reasoning, connecting dots and such. I think that's a better way, and that's the way I emphasize, but I still understand that some students don't like connecting that many dots, even though it's my opinion as pre-calculus students, you should be learning to connect those dots. That's really the point of this course. But a student that just memorizes the unit circle and isn't drawing these 2 right triangles, et cetera, they're still going to get full credit. The sine of 15 degrees. There's like 3 different ways to do that, as long as I don't say specifically what method to do. There's more than 3 ways, in fact. Then you're fine. Maybe you use the double angle method. Maybe use a half angle method. Maybe use a sum and difference formula. Maybe you have some weird arbitrary method that I don't even know about. If you can get the answer, that's fine, unless the problem explicitly states a method. And the main reason for that is There are answers in trigonometry problems that can be different in appearance based on the method you choose. The sine of 15 degrees is one of them. Whether you're using half angle formulas or sum and difference formulas, you can get a different answer for that one. So if the problem says use the half angle formula, you'd have to do that because getting the answer the other way would not be the same technical answer. Even though it's correct, it's different in appearance, and that makes a bigger issue, causes a bigger issue, I suppose. But again, 90, 95, 98% of the time, something like that, method doesn't matter. If you got a way to get the answer, that's fine as long as it's legit. All right. So talking about the course is pretty much done at this point. We still have an hour, so let's actually get into course material. And like I said, I like to use a lot of pre-recorded material. This half has been live. For the second half, for the sake of sanity and everything, we'll go to the pre-recorded stuff. And this is where I'll be able to be a lot more active in the chat. So I know I called out a couple answers here. It took me a couple more minutes to give some of those answers. But now when the video is going on, I'll be able to respond much more quickly. All right, so strap in. Let's start learning some trig, but we're going to start out by just dipping our big toe into the water. We're going to do a lot of definitions, a lot of simple stuff. No sine of 30 degrees today. We'll save that for another day. So 5.1, angles and their measure.
So we are going to pick right up with material, and we're going to start in 5.1 today. So we've already talked about the course. If you have any questions or confusions, you can always but we're going to stick to material today. So this is a class all about trigonometry. So we are going to study trigonometry, and let me just kind of take some of those away for now because I'm going to be doing some drawings on the screen. So 5.1, angles and their measure. The text actually changed the title to angles and radian measure, but that's fine. Doesn't matter. One thing I want to point out, if you ever see an incorrect section number, that is from us changing texts and additions numerous times over the past 6 years. I'm generally pretty good about having it correct as I'm going along, but I might accidentally refer to this as 7.1 or 6.1 because this chapter has been chapter 6 and chapter 7 in various textbooks before. All right, so angles and their measure. The first thing that we're going to talk about are rays. A ray is a part of a line with only one endpoint. So if you've been in Pre-Calc 1 and previous courses before that, and you know what a line extends infinitely in each direction. But a ray does not. A ray is just an endpoint, and then it extends forever. And it doesn't have to be pointing up and right. It can point in any direction like a clock. So that's a ray. It's part of a line with only one endpoint. Now, for the first couple times today, I will draw these little dots, they're endpoints, but moving forward in the class, the rest of the semester, I really won't ever draw those dots again because it just gets tedious. That's your ray. An angle is a measure of something. You can't really call it a distance. It's just the measure of kind of the relationship of one ray to another based on their positions and how they're opening up. So an angle is formed by two rays with common endpoints. So that point is what we call an endpoint. So this is two rays with common endpoints. And then we can say that it has an initial side and it has a terminal side. And that common endpoint has a name. Actually, we'll do it there. The common endpoint of those two rays has a name. We call it the vertex. Now, you've probably heard this term before in math, especially when you're talking about parabolas or quadratics. And you can even talk about the vertices or a vertex of other types of functions like an absolute value, et cetera, et cetera, et cetera. So that's why it kind of feels natural to call the point where two lines meet and end the vertex. So if we have something that looks like this, and let me draw them in different colors. So we'll do red on the left, we'll do blue on the right. and they're meeting at the same endpoint. So the point at which they meet is called the vertex. The initial and terminal sides can be up to you, but traditionally in trigonometry, we would say that the blue one in this instance is the initial side, and the red one would be the terminal side. So an angle is formed by two rays with common endpoints. The angle is this right here. It's the measure of how much you're swinging from the initial to the terminal side. And you always go initial to terminal. Traditionally, most of the time, we're going counterclockwise. Now, this thing that I just drew, that's what we call the Greek letter theta. Let me draw that just a little nicer. So again, it's the measure of how much we're swinging from one side to another, from the initial to the terminal. And we call that value theta. That's our angle. It doesn't have to be theta. There's lots of other variables we have. We have lots of Greek letters, alpha, beta, gamma, zeta, kappa, you name them. But this is kind of like our x. Theta is very, very, very much like our x. So again, it looks like a zero, but with this kind of curly part in the middle of it. Let me draw it a little bigger. There we go. Some people will have it kind of extended past that. It's got all sorts of different variations, but that is theta. Think of it as our brand new x. So we like to use x in algebra senses. We tend to like to use thetas for angles, for a lot of trigonometric senses. And again, the terminal side doesn't have to be on the left and the initial on the right. They can flip-flop. It's just a matter of whether it's a positive or negative angle, as we'll discuss later. Okay. So this angle right here would be the same as long as I keep the relationship of the terminal side and the initial side together, but I could rotate them however I like, as long as if I'm rotating the terminal, I rotate the initial side in the same manner. So let me try and just demonstrate that by drawing it maybe this way. See, it's almost 90, so this looks pretty good. That's me trying to draw the same exact theta. So going from the initial to the terminal, that's the same. I just drew them in a different manner. Instead of drawing them like going up left and up right, I drew one of them going just barely up and right and the other one going down and right. But how much we're swinging from one to the other is exactly the same in these two pictures. So there's literally infinitely many ways that you can draw an initial and a terminal side to represent the same angle. But that can create a little bit of chaos because we want consistency. We want to have some, well, standard position so that we can we can better understand the size of the angles, what they look like, what does 130 degrees look like, what does 270 degrees look like, what does 300 degrees look like, what does 85 degrees look like. So we need some kind of standardization. So our standard position has the vertex at the origin, and when I say origin, I mean of a standard rectangular coordinate system, or Cartesian if you know the fancier name for it. So the vertex will be the origin, so the point at which those two lines meet will be the origin. The initial side will be on the positive x-axis. The terminal side goes wherever it ends up. The terminal side will go wherever it ends up. So I'll leave that little memo, but we're going to draw. We're going to try and draw that same set of angles. So let's do black for our axes. That's not perfect. Let me do a little better than that. I think I mentioned before that I'm using a drawing tablet that I can't actually look at while I'm writing. So doing things straight is quite difficult, even with a ruler, in fact. So there's our standard coordinate system that you've used over and over and over and over and over. But our initial side is going to be on the x-axis. Then we said the vertex is on the origin, so there's the vertex. And the terminal side is just where it ends up. So this is going to go a little less than where the y-axis is. So again, it may not be perfect, but just assume I'm trying to draw it to demonstrate that it's the same. So this angle, this amount of space between them, and again going from initial to terminal, would be the same theta as before. So again, all three of those pictures are representing the same angle of measure between an initial and a terminal side. Drawing them this way or that way is fine, but drawing them this way is going to help us be more consistent and more understanding of the material. So this is how things are generally going to go. Now, I mentioned that the initial side doesn't have to be over here and the terminal over here. They can be swapped. You can, if you really, really want to, say that the initial side is here and that the red one is going to go below. So it's a matter of whether you want to rotate clockwise or counterclockwise. Positive angles rotate clockwise. Excuse me, I was about to say that incorrectly because I'm looking at the next one. Positive angles rotate counterclockwise. So we're starting here and we're swinging up. We're swinging up and then left and then down and then right. So again, this is the direction that we're swinging for a positive angles. For a positive angles, I just combined singular and plural. Negative angles are if you were to swing the other way. So if I did this instead, oops, a little squirrely. So x, y, let's say we still, and you still always have to have the initial side on the x-axis. That's always true. The initial side must go on the positive x-axis, not the negative, the positive. How do you know the difference? Negatives are on the left, positives are on the right. So now instead of swinging counterclockwise, I'm going to swing clockwise. So about there, roughly. So now we're swinging clockwise, but this angle right here would be opposite to the ones before. So let's just throw a random number out there. Let's say that this angle for the first three images I drew was 85 degrees. So this right here would be 85 degrees, which means this would be 85 degrees, which means this would be 85 degrees. We'll talk about what a degree is soon, if you don't know. But this right here, because we swung clockwise instead of counterclockwise, this would be counted as negative 85 degrees. And again, I'm not declaring that's what they are. They're in the ballpark. But again, if this is 85, this is 85, this is 85, but that makes this negative 85 because of swinging in the opposite direction, if you will. We will more often swing counterclockwise to get positive angles than clockwise to get negative angles. We more like to deal with positive than negatives. I think that's just true of everything in life. We want positive money, we want positive growth, we want positive angles. But that's not to say we can escape the negatives all the time. We say that an angle lies in a specific quadrant based on the terminal side. So you should have heard of quadrants in the past. Very, very quickly, and just with the abbreviation of Q, the top right is supposed to be quadrant 1, the top left is supposed to be quadrant 2, the bottom left is quadrant 3, and the bottom right is quadrant 4. And if you had algebra teachers who don't like to explain why things are, which is very common, you probably wondered why you didn't go 1 here, then 2 here, then 3 here, then 4 here, or maybe go 1, 2, 3, 4. Why were they going counterclockwise and starting in the top right? Here's the reason. Because when your initial and terminal sides are on the positive x-axis, when they're the same line, we call that 0 degrees. And as that terminal side, as the red one, swings, we go to 1 degree, 2 degree, 3 degree, 4 degree, 5, 6, 7, 8, 9, 10, blah, 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 until we hit about 90 degrees. So from 0 to 90 degrees is in quadrant 1. Then as we keep swinging counterclockwise, we go to quadrant 2. Then eventually we end up quadrant 3. Then eventually we end up in quadrant 4. The entire labeling of quadrant numbers is based on trigonometry and positive angles as they go from 0 all the way up to 360, or even more if you keep going around more. So this angle that I've drawn here as a positive angle, this would lie in quadrant 1. I'm going to erase this in just a second. But that would be an angle in quadrant 1 because its terminal side is in quadrant 1. However, when I did it as a negative angle, as a roughly negative 85 degrees, this would be in quadrant 4. Now that doesn't say that you can't have a positive angle in quadrant 4, because I could have swung through quadrants 1, 2, 3, and then got to 4. And we're going to talk about that idea very shortly. So again, that first image is in quadrant 1. This other one is in quadrant 4. I don't really want to make that statement about the two up here because they're not drawn in standard position. So that's another benefit of standard position, is that we can talk about what quadrant it's in. And a lot of the math and trigonometry is based on the quadrant. Spoilers, there's this rule called a smart trig class that ASTC tells us some of the positives and negatives based on what quadrant we're in. All right. This is something that we'll discuss numerously throughout the semester, constantly throughout the semester. What is a quadrantal angle? Well, a quadrantal angle means that the terminal side lies on an axis. It could be the x-axis or the y-axis. It could be the positive or the negative of said axis. These are very important to understand, that a lot of the basic principles of memorization, they work differently for quadrantals than, say, 30 degrees or 60 degrees or 45 degrees. 90 degrees, some of the features of it just are different. And again, I'm really jumping the gun and doing a lot of foreshadowing here that, maybe I shouldn't do, but I like to. So if an angle ends up lying on one of these axes, it's kind of a special case. It doesn't mean that a lot of things are different, but you have to understand the different aspects of it. So you've heard me say 85 degrees numerously now. What exactly is a degree? Well, it's one of the ways to measure an angle. Kind of like feet is a way of measuring distance. Kind of like degrees Fahrenheit is a way of measuring temperature, or degrees Celsius is a way of measuring temperature. And I chose that one intentionally because they're not related at all. Degrees, in terms of an angle, have nothing to do with degrees and temperature. It's another one of those, the word has two kind of definitions. So don't think that just because I say the word degrees, I'm talking about temperature. In fact, as a mathematician, when I want to talk about the temperature outside, I don't just say it's 90 degrees, I'll say it's 90 degrees Fahrenheit, because 90 degrees isn't well labeled, and it would make you think, oh, it's a right angle outside. That's the temperature. Wait, that doesn't make sense. So I hope that you have kind of been accustomed to some talk in the real world. You talk about people doing a 180. That means that they turn around. They were moving forward and now they're moving backwards, or they were moving left and now they're moving right. Or maybe you've heard of someone talking about going a full 360. That's not turning around, that's turning around completely and facing the same direction. It's one complete rotation or revolution, if you will. So 360 degrees means that we've gone all the way around the entire system. So let's say we have our initial side here, and I'm going to kind of try and put it on the top of that. And then our angle goes all the way around through quadrant 1, 2, 3, 4, and then ends up on what we would have normally called 0 degrees. So that means that our initial and terminal side are actually the same. They should be drawn on top of each other, but then they're going to cover each other up. So I'm just trying to kind of superimpose them by like a millimeter off of each other. So that angle right there, again, this little circle, that's not a circle, that's just demonstrating that we rotated all the way around. That would be 360 degrees. Please, I'm going to erase these arrows in a second. Please, please, please do not ever forget that. If you are talking about an angle in degrees, you have to have that little zero looking exponent. That is not a zero exponent, that is a symbol, in the same way that we write FT to symbolize feet, or the same way that we write L cubed to describe a cubic liter, a measure of volume. So this is not an exponent of zero. That does not mean that this is 360 raised to the power of zero, which would be 1. This is just a new symbol. So that's the degree symbol. So if you start at the positive x-axis, rotate through quadrant 1, 2, 3, and 4, and then stop at the same line, that's 360 degrees. If you keep rotating, you'd be at 361 degrees, 370 degrees, 450 degrees, 540 degrees, 545 degrees. Eventually, if you go around 2 full circles, that would be 720. If you do 3 full circles, that would be a 1080. Maybe some of you are into sports with boards involved, and you talk about them doing 540s and 720s and 1080s and things like that. So that's because they're doing 1.5 or 2 or 3 full rotations or revolutions, same word. If you have a test problem that does not have the degree symbol built into it, or a homework problem, if it doesn't have that symbol built into it, then you would have to make sure you write it. When you're showing your work for your test that you have to submit, you have to make sure that you're writing this. Now, am I going to take points off if it's missing on 1 or 2 spots of your work? Honestly, probably not if you have the answer right. If it's missing everywhere, that's another story, and that's when I'll start saying you need to be better at your symbols. Because guess what? If you don't write that little circle, if you don't write it, you're saying that it's something called radians. If it's just a number written, it's 360 radians, and that is something completely different. Let's pause on that, though. A couple of basic geometric definitions you may be a little rusty with that we'll use quite often in here. Any angle that is less than 90 degrees, I should say any positive angle less than 90 degrees, we call that acute. Oh, look at the cute little angle. It's a cute little angle. Sorry for the silliness, but that's how I remembered it as a kid. It's small, it's acute. A right angle, it's not that it's correct, it's just a name for 90 degrees. We will say that term 10,000 times throughout the semester. We love right angles. We love them. We love right angle trigonometry because it simplifies things. Obtuse, and I don't mean like obtuse as in being dense. Obtuse, I have a word that I associate it with it, but it's just one of those things that I don't want to put it in a recording, so I'm not gonna. If I was in a classroom, I'd say it, but it's not bad. I just don't want to say it. I don't like things being recorded. I really don't. And then someone comes back 5 years later and I get canceled because of it. You know what I'm saying? Sorry, again, I have a silly sense of humor. So obtuse, think wider. Obtuse, so that's between 90 and 180 degrees. So an acute angle, and I'm going to skip well, no, I'm not for now. I'm going to skip doing the colors eventually. For now, I'll keep doing it. I'll also skip drawing the arrows eventually. So this would be an acute angle. Spoilers, if something's written in standard position, all acute angles end up in quadrant 1. These will always be in quadrant 1, in standard position. Because 90 degrees is the positive y-axis. I'm going to label all those quadrantals shortly. A right angle is 90 degrees, which I just mentioned. So initial is blue, terminal is red. So there's our right angle, our 90-degree angle. An obtuse angle is something between 90 and 180. So that means it's in quadrant 2. So if your initial is here, that means your terminal is somewhere over here. So this could be like 130 degrees, 170 degrees, 141 degrees. That is an obtuse. All right, and since I didn't label it up there above where it said quadrantals, let me just come down here and make a little memo. Oh, it's a page break, that's why. I'll give you a second to finish writing that stuff first. And I'm gonna mute because I got a cough bad. All right. Cool. And remember, if I ever go too fast, if I'm going super fast, someone can speak up and I can scroll back. But if it's a matter of, I just went a little too fast, you can always catch the recording. Yeah. So what are the quadrantals? So someone just asked, is a right angle in quadrant 1? And I'm going to say yes and no, kind of, maybe, sort of. And I'll describe why that is as soon as I finish these drawings. Oops, that was a little wide. And I'm going to skip doing the X and the Ys. So I think I was doing initial for blue and then red for terminal. So that would be 90 degrees. That's your first quadrantal. Let me describe the swing. There we go. The second right angle, the second quadrantal would be initial here and then terminal here. So we have swung from the positive x-axis over to the negative x-axis, and that is 180 degrees. That's our turnaround. Also known as a straight angle. You can see that definition down there. Then we have our, oopsies. Oh, I said I wasn't going to label that anymore. Blue here, red here. So this would swing through quadrants 1, 2, and 3. So that would be 270 degrees. Every quadrantal is a multiple of 90. Spoiler if you haven't figured that out already. And the next one, which we've already basically mentioned, where your initial and terminals are on the same spot. Initial, we rotate our full 360 degrees. Terminal. So this is 360 degrees. Comma, and I'm putting the comma in front of it, because guess what? If you don't rotate all the way around, it's also 0 degrees. If your initial side is here and your terminal side is here and you haven't swung at all, that's 0 degrees. It's also a quadrantal. So 0, 90, 180, 270, 360. Every multiple of 90 degrees are quadrantal angles. So to answer the question asked previously, is this 90-degree angle in quadrant 1 or is it in quadrant 2? The answer technically is neither. It is not in a quadrant because it is on the dividing line of the quadrants. It's between quadrants 1 and 2. So you can't say that quadrantals are in a quadrant. They are separated by 2 quadrants. 180 degrees is separated by quadrant 2 and 3. 270 degrees is separated by quadrants 3 and 4. 0 or 360 or 720 or 1080, etc. They're separated between quadrants 1 and 4. So that was an excellent question. Okay. Give you about 20 more seconds to finish drawing those. And let's do this. Let's leave some space there for my drawing. Okay, so a degree is one way of measuring an angle, and it is generally most students' favorite version of measuring an angle. But it's not the only way to measure an angle. And in fact, sometimes we can't use it. There are times when you can always, I don't want to use the word always there. There are times when you can use degrees, but there's also times when you can't. The cool thing is with radians, you can always use them. And we're not ready to talk about the why and when we can and can't use either one. Radians are always usable. Degrees are usually usable, just so you know moving forward. And we'll talk about when you can and can't, when it becomes necessary. So the other type of thing, so we have degrees Fahrenheit in temperature, and we have degrees Celsius in temperature. Yes, we also have degrees Kelvin, but no one uses Kelvin because none of us are measuring things that are super, super cold. Otherwise, what's the point? You have feet, you have meters. They're both units of distance, but one is the SI system and one is the metric system. Heck, we have different units of measurement in a single system. We have feet and we have miles. So a radian is to a degree like a foot is to a mile. They're just two different ways of measuring things. I don't mean that it's a ratio of 5280 between them. There is a ratio between them though, and we'll talk about that shortly. So a radian is a second way to measure an angle. When you're talking about radians, you do not have that little exponent 0 thing, that symbol that symbolizes degrees. So something that's in radians, again, does not have that little 0. Also, when we are dealing with radian angles, almost always, I'm willing to say 98, 99% of the time, there's going to be a pi somewhere in there. And you're not going to write the letters PI for pi. You should use the symbol. It's just when I typed these notes, Word was being a pain in the butt. And it didn't want to put the symbol in there. So a radian is a second way to measure an angle. 2 pi is 1 complete revolution. So for radians, 2 pi is now a complete revolution. So if in degrees, 360 degrees is 1 complete revolution as seen here, that means that 2 pi is the same thing. So 2 pi is the same as 360 degrees. That's our jumping off point that we'll see. But before we get into that aspect, let's actually try and understand what a single radian is by definition. So this is a definition. This isn't something that you could just deduce. The definition of a radian is that one single radian, so 1 feet, 1 mile, that kind of thing, 1 rad, 1 radian, is the angle that makes the outer length of a circle the same as the radius. So let's draw up a circle. Let's draw up a circle. And here's the center. And let's have our initial side be here. And I'm going to label that R for the radius. So that's the radius of this circle that I just drew. Then my terminal side, in order to make this happen, it has to be about here. You just got to trust me that it's about here. Now, if that's the radius, this has to be the radius because the distance to the center to the edge of a circle is always the same distance, the radius. So this distance is the radius, so this distance is also the radius. And the idea is that 1 radian, so radian kind of sounds like the word radius, right? I bet there's a reason for that. It's the angle that is formed that makes the outer length of the circle. So let's go with orange. This distance, this curvy, this bendy distance right here, this arc is actually the official name. This arc is exactly the same as the radius. So in other words, if this blue distance was 5, the red distance would be forced to be 5, and a radian is this specific angle so that the distance along this arc would also be 5. So again, that was just a random example. If this was 5, that means this is 5, and this is 5. All of those distances would be the same. 2 of them are straight, 1 of them is bendy, 1 of them is an arc, the arc of a circle. So right here, again, swinging in this direction, that angle would be 1. It's just the number 1. When you don't write units, you assume that they're in radians. And you might say, well, Mr. Beckner, I had you for pre-calc 1, I had you for quantitative reasoning, and you said always write units. Well, the thing with trigonometry is you see these things so much, it is a basis that you don't write it. Kind of like when you have a coefficient of 1, you don't write it. Kind of like when you have an exponent of 1, you don't write it. Kind of like when you have a square root, you don't write the 2. It's something that is used so absolutely freaking much that you don't want to have to write radians or RAD every single time. It gets extremely tedious. That is a major point to understand day 1. Degrees are not the same thing as radians. Degrees, you have to write that little circle, that tiny little circle as an exponent so you can tell it's a degree. Because if I do this, pay attention to where I am. If I do this, now that's in degrees, and this is no longer true. That angle is not 1 degree. It's much larger than 1 degree. It's more like 80-some degrees, 70-some degrees. Sorry, I got distracted at home. Give me about 20 seconds. Okay. Sorry about that. Dog issues. And actually, I just realized that the numbers I was saying was too high. It's not 80 or 70. It's more like 60. Yeah, it's like 60. So I drew that a little too, the red is a little too high, but don't worry about that. This is not a diagram I'm going to expect you to understand and know. But what is good to know, let's do this again. A little oblongated pronunciation is important. Circle. So let's have our initial side be here. Terminal side be here. Again, the center was obviously in the center. This would be 180 degrees because it's a straight line. We've swung from the positive x to the negative x-axis. So this would be 180 degrees. In degrees, but in radians, it's pi. Why is it pi? Because 2 pi is 1 complete revolution. This is half a revolution. So here's the image of the complete revolution. Center, initial, rotate all the way around 360 degrees. Terminal, like I said, I'm not going to draw those arrows all the time. I generally don't do it anymore unless it's necessary. So that angle, I drew the circle a little too much out. This is the angle. There we go. Kind of looks like a bullseye. That angle, because it's a full revolution, is 360 degrees, but in terms of radians, it's 2 pi. You've seen 2 pi in some formulas before, some geometric formulas. C equals 2 pi r. Circumference is equal to 2 pi times radius. You know how the number pi was established? Someone wanted the ratio of the circumference and the radius. That's how pi was established as a number, that 3.1415927 something, blah, 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 blah. You only need to know it to 3.14 as an approximation, but we generally don't even need that. So pi as a number is 3.14, which means this is 3 radians and just a little more. This is 3.14 radians if you go from 0 to 180 degrees, if you go half a circle. If you go all the way around, that's 2 pi. 2 times 3.14 is 6.28. So if you wanted just a decimal approximation. So 360 degrees is about 6.28 radians. It's exactly 2 pi radians. But again, just if you wanted a more tangible number for that. So it's these two statements, either one, that gives us the ratio that we can use to convert from radians or degrees, which we'll be doing constantly throughout the semester. So we said a full circle is 360 degrees, which means 360 degrees is 2 pi radians. Or you could use a simpler version of that without the 2. Half a circle was 180 degrees, and that was just a single pi. So 180 degrees is pi. This is the better one to use for your conversion process because it's just smaller numbers, it's less numbers. So that tells us, if you understand the concept of dimensional analysis, if you have a unit conversion like 180 degrees is pi radians, that means to go from one to the other, you're just multiplying by those things as a fraction, one on top of the other. It's just the which one goes on top and bottom is dependent on what you're starting with and what you're ending with. Here's what I always like to say, and I'm going to add this. Out with the old, cancel units, new. If you're in degrees starting out, that means your multiplier needs to have the degrees value in the bottom so that those things would cancel top and bottom. If you're starting out in radians, then you'd need the pi radians in the bottom so that the units of radians cancel, leaving you with degrees. I'll even show you what this would look like if you did it wrong one time, because you might be a little rusty with your dimensional analysis. Another shortcut, I almost call it a cheat because it really simplifies things. Like I said earlier, 98, 99% of the time, if you're talking about radians, there's a pi somewhere probably. So if your original number has a pi, you're going to need the pi in the bottom to get rid of it because we generally don't see pi in degrees. So if your original number doesn't have the pi, then you probably need the pi in the top so you end up with it, and you don't get it in the bottom. I'm trying to decide if I want to keep with the definitions. Let's go ahead to examples. Just give myself some space. I'm going to leave this up here. So finally up to some examples today. Example 1 will be converting to radians. And for A, we're going to have 30 degrees. Terrible looking 0. Let's try that again. I am going to do this right, and then I will do it wrong, and I will erase the wrong version afterwards, but let's do it right. So we got to multiply. We're in degrees, we're converting to radians, so we're going to multiply by a fraction with those conversion factors, one top, one bottom. It's either pi over 180 or 180 over pi. So because we're in degrees, we're converting to radians, we need the pi in the top and the 180 in the bottom. I usually don't write the word radians as I've already described, so I'm just going to do pi over 180 degrees, but I will always write the degree symbol. That's forced. And in fact, I meant to write equals and then do the multiplier. Let me just start over. Sorry. 30 degrees times fraction. Nothing I did was wrong. I just wanted an extra step written. And then the pi over 180. So when you do this, 30 and 180 reduce. You've got to know how to reduce your fractions. 30 would go in 180 6 times. But the bigger number's in the bottom, so that means the 6 is going to go in the bottom. So there's a degree in the top, there's a degree in the bottom, so those units cancel each other out. I'm going to erase the canceling, but they will cancel each other out. So there's no more degrees. The 30 and the 180 reduced to a 6 in the bottom. The pi, there's nothing to cancel it, so we keep it where it was. So the answer is pi over 6. Pi over 6 radians if you want to write the unit, but I just say pi over 6. Again, without the degree symbol, it's a perfect assumption. There we go. B. Oh, no, I said I was going to do it wrong first. So, and actually I won't erase it. If you took your 30 degrees and you multiplied it by, red for wrong this time, let's do 180 over pi. So first of all, now the 30 and the 180 are being multiplied, so 30 times 180 is going to be 5,400. the degrees of this one are on the top, the degrees on this one are on the top, and if you add feet times feet, you get feet squared. So a degrees times a degree is a degree squared? What in the world is that over pi? You are never ever going to see an angle that looks like 5400 over pi in here. Just trust me. But the units, if you pay attention and you process things accurately like a pre-calc to calc student should be doing, then you would see this just goofy mess that says no, bad, stop, redo. All right. I looked at the time and I thought our class was done. I was like, there's no way it took us an hour and 15 minutes to get this far. It throws me off that our class starts at 12:30. That's all. Next up, let's do 60 degrees. I'm going to do a lot of ones that you'll see over and over throughout the semester. So we know we're going to multiply by a fraction, and we're going to do it right every time from now on. So you might say, all right, well, we did pi over 180 last time, so I know what it's going to be for the rest of this example, but don't just know how to do something consistently, know how to do it if you're going back and forth. Why is it that we're multiplying by pi over 180? Because this has degrees in the top, so we have to have the 180 degrees in the bottom to cancel those units, forcing the pi to the top. 60 and 180 reduce. 60 goes into 180 3 times, which means the bottom is now a 3, the 60 is gone. So you could put a 1 here if you wanted, but since the pi is still on the top, you don't need to. So that's the answer, and I meant to do that in black. So 60 degrees is pi over 3 radians. C, 45 degrees. 30, 60, 45. These are 3 of the most used angles throughout this course. You will see them in radian format constantly. And a lot of students don't like doing the math in radians, so in their head, they just convert them to degrees. They may not show it, they may show it. It's up to you. But the important aspect is knowing how to go between one and the other. So we're in degrees, so we know degrees goes in the bottom to cancel. We know the pi goes in the top to fix everything. 45 will go into 184 times, so that's a 4 in the denominator. The degrees would cancel each other out, and the pi is still in the top. Let's do D over here. Ooh, I'm gonna have a hard time getting all of those up here. That's all right. Squish it in just a little bit. That's why I didn't want to have the wrong bit over there, but that's okay. I want to leave it. It's good to see. For D, 90 degrees, another extremely popular angle that we'll deal with all semester long. So we multiply by a fraction. Oh, I forgot to do the equals. By a fraction, clearly pi over 180. Out with the old and with the new. 90 and 180 would reduce to half. Pi stays in the top. So pi over 2 is the answer in radians. So 90 degrees is equivalent to half of pi. I feel like that one makes sense because 180 degrees is a full pi, 90 is half of pi, pi over 2. I'm going to try and squish this in here. E, 120 degrees. Popular, but not as popular as the rest. Multiply by pi over 180. Degrees. 120 and 180 will not divide perfectly, but they will reduce. 60 goes into both. 60 goes into 120, excuse me, twice. 60 goes into 180 thrice, or 3 times. The pi needs to stay in the top. There's 2 ways you can write this. You can write the pi in the top or to the side. Both of those are accurate answers. F, last one for this example, 135 degrees. So we're going to multiply by pi over 180 degrees. The degree units cancel. Let's see, 45 is going to go into both of these. And you can reduce them slower, but I do suggest trying to reduce them with as big of a number as possible. You could say, all right, 5 goes into both of these, and then 9 goes into both of them. or 3 goes in, and then 3 goes in, and then 5. However you're reducing, just get the job done completely, because if you don't reduce completely, your answer is wrong. Now, in bigger problems, a non-reduced answer could get you partial credit, but if I gave you an example like this on a test, I would not give you credit for a non-reduced answer. And that brings me to a very important point. These are not test questions. These are not test questions. These are not test questions. This is like 1 + 3 for us. This is something that you need to be able to do every day, every week, every month of the semester. I will never give you a test question where the whole goal is just to convert this. And I'll explain what students do wrong in that regard when it becomes relevant in a few classes, maybe next class. All right, so 45 goes into 135 3 times, into 180 4 times, so that's 3 pi over 4, or 3 over 4 pi. I'm not going to write it the other way. You can drag it to the side if you like. It's up to you.
I didn't actually mean to reduce that. I mean, to make the window go away. So we just have a few minutes left, and we're not going to be able to finish the next subset of examples where we go the other direction. So we're just going to save those for next time. I think we've done enough for today in our almost 2 hours together, and you probably need a break. So that being said, I hope this was an informative day. I hope I didn't confuse anybody with the first half, or of course with the second half as well when we actually got into some material. But as usual, and I'll always say, you can email me with any questions. Again, rbeckner@tcc.edu. This entire lecture, this 2-hour lecture, will be on YouTube and then linked in Canvas, and the video should be available within. You okay, buddy? Sorry, my dogs. I told you, they're very distracting. This is why we use the pre-recorded stuff, and I don't just have dogs. So, where was I going with that? Email me. Make sure you sign in Mymathlab. Make sure you have your account. I think I've got 7 people now. So do that by 5 p.m. tomorrow. I do not want to delete anybody. I'll probably be sending out emails at 5 p.m. to anybody who needs to do it. Give you like 1 more hour, because I'm lenient if you still get it in tomorrow, quite honestly. I just like to say 5 p.m. to, give it a little more vigor. But we will pick up where we left off by doing this process backwards next time, as well as getting into many, many more things. But for now, have a good day. It was awesome to meet y'all over the internet. You ask me any questions over email, and we'll see you on Thursday.